Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel Higher 2 paper from 2019 and this is paper 2 and we're on question 18. So this is a question about angles within a circle, and what we've got is an isosceles triangle which is ABD, and we've also got another isosceles triangle BCD. And together they form a cyclic quadrilateral as well. So ABCD is actually a cyclic quadrilateral. And so let me just write that down. ABCD is called a cyclic quadrilateral. And what that basically means is a four-sided shape, which is in a side circle where every one of the vertices, the corners, touches the edge of the circle. So that's what a cyclic quadrilateral is. And there's some rules we're going to use about that, or some properties about that we're going to use within this question. So what we're asked to find is the size of angle ADE, which is this one here. So the angle we're looking for is the one that's at the middle letter there. So at angle D, at point D, and it's the one that's formed by joining a line from A to D and then D to E there. So when I'm doing these types of questions, I find the easiest way is, if I'm not sure exactly of how to get straight to the answer, is just find every angle that you can, and then usually the answer will drop out eventually. So we can look at this first of all, this triangle ABD. So ABD, which is an isosceles triangle, and we know that because of these two marks on the lines there, which tell me that those two sides are the same length, which means that it is an isosceles triangle because it's got two sides of the same length. So that's isosceles. And because of that, one of the properties is that the two base angles are the same, which would mean that this angle and this angle are the same. And because we know that angles in a triangle add up to 180, we can take away this 40 degrees from 180, divide by 2, and that will give me angle, this one at A and this one at D. So I need to give a reason for every stage of my working as well. So I can't just write down the answers. So what I want to do is get used to this three-letter notation. So if I say BAD, then that's referring to the angle that's at A, formed by the lines BA and AD. So BAD is equal to 180 minus the 40 at the top divided by 2. And I can give them a reason, just put it in brackets. I'll just say that it's isosceles triangle. Isosceles triangle. There we go. Bit messy the writing there because of the pen I'm using here. But anyway, so if I just work that out, so that's 140 over 2, which is 70. So I can put this on my triangle now. That's 70 degrees. I can also say that BDA must equal also 70 degrees. And we can say, well, that must equal BAD, again, because it's an isosceles triangle. So that's 70. I'm now going to look at the other isosceles triangle there. This is BCD. Okay, so we can see that's an isosceles again because I've got these little marks on the lines which tell me that BC equals CD. So I'm going to try and find this angle here, BCD. So BCD. Now, there is a rule that because I've got a cyclic quadrilateral, as I mentioned before, A, B, C, D, then the opposite angles in a cyclic quadrilateral add up to 180. So this one here, the 70 degrees, and the angle that I'm trying to find at C must both together add up to 180 degrees. So what I can say is BCD is equal to 180 minus this one, 70 degrees, and my reason would be opposite angles in a cyclic quadrilateral. Okay, and so that will give me 110 degrees. So that's BCD. Now, that then allows me to find, so I'll just put that on there, 110. That will now allow me to find these two angles, but using the same isosceles triangle logic that we used before. So we can say that since BCD is isosceles, then we can say that angle BDC is going to be equal to 180 minus the 110, and then divided by 2. And that's because I'm dividing by 2 because this angle and this angle are equal to each other. So together they make 180 minus 110. If I divide it by 2, that gives me what they are worth individually. So I could put as a reason here, so base angles in isosceles are equal. So if I work that out, then I've got 180 minus 110 is 70. Divided by 2 will give me 35 degrees. So this one here is 35. And we're now in a position to be able to find the angle we're looking for, which is ADE. And what we've got is that the 35 degrees, the 70 degrees, and the angle we're looking for are all on a straight line. And angles on a straight line add up to 180. So we can just add the 70 and 35 together, take it away from 180, and then we've got the angle we're looking for. So what we can say is ADE is going to equal 180, because this angle's on a straight line, but then minus those two added. And I'm going to use a bracket just to show what I'm doing. So 70 plus 35. And so we've got the reason angles on straight line add to 180. Okay, so that's 180 minus 105, which will give me 75 degrees. And we've done it. That was the angle that we were looking for. So I hope that's been helpful. If it has, please like our page, our website, our video, and subscribe to our channel, which is Gary Teaches Maths. And for more help, look at our website, which is bestmathstutors.co.uk. Thanks for watching.